All right, guys, welcome to Modern Education during the zombie virus. Okay, this will be the first video for the week. There'll be more to come later on in the week. We're going to go back and we're going to talk about some topics that we had started on right before this whole crisis came into play. One of the last things we were talking about was dealing with the measure of an inscribed angle as opposed to a central angle. Now remember, an inscribed angle, okay, is an angle inside a circle whose vertex is on the circle, okay? That obviously is different from a central angle. Boy, that's a bad looking circle. Okay, so remember, a central angle has its vertex at the center. Okay, so in this case right here, we know that the measure of the central angle, angle ACB, is the same as the measure, and remember this is arc measure, not arc length, arc measure in degrees, is the measure of the intercepted arc. Be the same as the measure of arc AB, like this. Okay, so for instance, if the measure of the central angle ACB was, say, I don't know, 85 degrees, then that means the measure of the intercepted arc would be 85 degrees. Okay, so obviously with a central angle, we know that the measure of the angle and the intercepted arc have the exact same measure. But now here with an inscribed angle, it's different, okay? The measure of an inscribed angle will be half the measure of its intercepted arc, okay? Half of that, okay? So for instance, let's suppose the measure of arc AB, okay, was, say, I don't know, let's make it 100 degrees, like that. Then the measure of inscribed angle ADC has to be half of that. So that would be 50 pesos. Okay, and I'm pretty sure we talked about this right before we went on hiatus. Okay, so I'm sure you guys will be fine with this. Okay, so if we have some situations like this, okay, find the measure of each inscribed angle. Okay, so if we take a look at this top left one, notice that angle ADB is an inscribed angle because its vertex D, okay, is on the circle. So the measure of that inscribed angle has to be half the measure of its intercepted arc. So if we take 96 pesos, the measure of the intercepted arc, and divide it by 2, okay, we're obviously going to get 48 pesos. Okay, so in this case, the measure of inscribed angle ADB is 48 pesos. Not a problem. Okay, so let's see this top right. Okay, now the problem with this one is if we look at the inscribed angle, angle PSR, the intercepted arc is arc PR, and we don't know what that measure is, but we can easily find it. Notice that arc SPR is a semicircle. So we know the measure of arc SPR has to be 180 degrees. So if we know that arc SP is 84 degrees, then arc PR has to be 180 minus 84. Okay, so that would be 180 minus 84. Okay, so that is going to give us, what, 96 pesos? If you need to check it, pull out your Walmart special. Make sure that you have the right answer. It's 84, and we've got 96. Okay, so the measure of the inscribed angle PSR that has an intercepted arc measure of 96 has to be half of 96. So once again, if you take the 96 degrees and divide by 2, notice that we already did that in the first one, so that's 48 pesos. So the measure of angle, inscribed angle, PSR, has to be half of 96, so that's 48 pesos. And we're in good shape. Okay, now we move to these guys down here. Okay, same situation, shouldn't be a big deal. Okay, notice that we have inscribed angle, XWZ, and its intercepted arc, okay, is 75 degrees. So the measure of inscribed angle XWZ has to be half of 75. So we take the 75 pesos, divide it by 2, and if I remember correctly, that should be, I think 37 and a half, but I'll check it to make sure. 75 divided by 2, yes, 37 and a half. So that would be 37 and a half pesos. Okay, so the measure of inscribed angle, angle XWZ, would be 37 and a half pesos. Okay, so, and if you wanted to leave that as 75 halves pesos, that's okay too. Obviously, that's 100% correct. But as you've seen in the past, when we're talking about measurements, I don't like to use the improper fractions. I like to use mixed numbers because I have an easier time thinking about that in my head than I do with this guy. So either answer is correct though. Okay, so we come over here, and again, we have inscribed angle ADB, and its intercepted arc is AB. So the measure of the inscribed angle has to be half the measure of the intercepted arc. So again, I'm gonna have to take 159 pesos and divide that by 2. Okay, and so again, we go to our trusty guy, okay? 159 divided by 2, and I am gonna get 79 and a half. 79 and a half pesos. So the measure of intercepted angle, I'm sorry, inscribed angle, not intercepted angle, inscribed angle, ADB, is 79 and a half pesos. Okay, so we're in good shape there. All right, now, these are the types of problems that we sometimes see on the end of the year test, okay, where they give you an inscribed angle, okay, and they give you a central angle as well, okay? So notice that the inscribed angle, angle ADC, has intercepted arc AC. And the central angle, angle ABC, has the same exact intercepted arc. So we know that a central angle has the exact same measure as its intercepted arc. So central angle ABC has to be 46 degrees. So that has to be 46 degrees. So we know the measure of central angle, angle ABC, is 46 pesos. Now we have an inscribed angle, angle ADC. It has the exact same intercepted arc, but the measure of an inscribed angle has to be half of the measure of its intercepted arc. So this guy has to be half of 46, which is 23 pesos. So the measure of inscribed angle, angle ADC, is 23 pesos. So notice right here, this relationship, if you have a central angle and an inscribed angle, and they have the exact same intercepted arc, the measure of the central angle is always twice the measure of the inscribed angle, or you could say the measure of the inscribed angle is half the measure of the central angle. Okay. All right, so let's see this guy over here. It is the same situation, just a different looking diagram. So if we look at angle ABC, notice that, assuming that point B is the center, we have a central angle. And notice that the intercepted arc is arc AC. So we know that the central angle has to have the exact same measure as the intercepted arc. So that has to be 93 pesos. So the measure of central angle, ABC has to be 93 pesos. Okay, now we look at angle ADC. Notice it's an inscribed angle because the vertex is on the circle, but notice it has the exact same intercepted arc. Okay, so its measure has to be half of the measure of the intercepted arc. So I have to go 93 pesos divided by 2. Okay, and again, we go to our trusty Walmart special, 93 divided by 2, and you get 46.5 pesos. So the measure of inscribed angle, ADC, equals 46.5 pesos. And again, notice that these two angles, the central angle and the inscribed angle, have the exact same intercepted arc, arc AC. Therefore, the measure of the central angle will be twice the measure of the inscribed angle, or we could say the measure of the inscribed angle is half the measure of the central angle. Okay. All right, let's see what we got going on this guy. It wants us to find the measure of the inscribed angle. Okay. All right, so we know something about the measure of the inscribed angle, angle ABD. We know its measure is 7x minus 9 pesos. And we know the measure of its intercepted arc, AD, is 12x plus 6 pesos. Okay, so we have two different ways that we could look at this. And this basically goes back to this first slide we were looking at, where we could say the measure of the inscribed angle is half the measure of the intercepted arc. Okay, so we could say, one way to deal with this, we could say the measure of the inscribed angle, ABD, is 1/2 the measure of the intercepted arc. So it'd be the measure of arc AD. Okay, that's one way to look at it. Or we could say, well, isn't that the same as 2 times the measure, okay, of the inscribed angle, 2 times the measure of angle ABD has to equal the measure of the intercepted arc, measure of arc AD, like that. Okay, so let's see. Either one you could use. If I had to guess, I would say that most people in my geometry classes would probably go to this guy, but it's okay. You could use either one. It's not going to be a problem. But this is where I think you'll probably go, so I'll use that guy. Okay, so we go 2 times the measure of angle ABD, and ABD is 7x minus 9. So we're going to have 2 times 7x minus 9 here equals the measure of arc AD, which is 12x plus 6. And this is a pretty easy equation to solve. You probably learned how to do it in middle school. So let's see, using the distributive property, that'll give us 14x minus 18, and that's equal to 12x plus 6. Okay, so if I subtract 12x from both sides, that'll give me 2x over here. And if I add 18 to both sides, that'll give me 24 over here. So x has to be equal to 12. Okay, so now we have to go back and it says find the measure of the inscribed angle. So I want to find that measure. So I have to use x equal 12. And obviously I want to take a look at this so we make sure that we can check to make sure our answer is correct. Okay, so let's see. The measure of inscribed angle ABD is 7x minus 9. So I would get 7 times 12 minus 9, and remember that's an angle measure, so that's in pesos. So you go right to your trusty Walmart special, 7 times 12 minus 9, and I am coming up with 75 pesos. Okay, so it looks like this guy right here should be 75 degrees. So I should get twice that here for 150 degrees, so we're going to check it. So we get the measure of arc AD equals 12 times x, so that'd be 12 times our 12 plus 6. Well, 12 squared is 144 plus 6 is 150. Okay, so that means this guy is 150, and that works out. Notice the measure of the inscribed angle is half the measure of the intercepted arc. Okay, guys, that's the first video of this week. There will be more to come. Everything you need is on Google Classroom. If you have any questions, post your question on Google Classroom or just shoot me an email. You make sure you stay safe out there, and I miss you all a whole bunch.